In this video, we are going to use the differential equation and project the death toll for the coronavirus for April 1st to April 5th. And and today is March the 31st, and this morning the death toll was 3141, which is really by the end of yesterday, and the day before yesterday the death toll was 2583. So let's assume that March 31st, which is today, is 0, March 30 is -1, March 29 is -2, and April 1 is 1, April 2, 2, and so on. The general formula, the general differential formula for a growth rate is written as dy over dt, change of y with respect to t, is equal to k times y, where y is the population, t is the time, and k is the growth rate. So let's go ahead and solve this differential equation. We can use the separation of variable method and solve this equation. We can rewrite this equation as dy over dt is equal to, dy over y is equal to k dt. Now, in order for us to solve this, we take the integration of both sides of this equation. So on the left side, we are going to have natural log of y is equal to kt plus a constant. So if natural log of y is equal to that, so y itself will be equal to e to the power kt plus a constant. So we can rewrite this as y is equal to e to power kt multiplied by e to power c. So e to power c is again a constant. So we can rewrite this equation as y is equal to a constant c e to power kt. So here y is the population and e to power kt, k is the growth rate and t is the time. And this constant, let us show that constant as y is equal to y0 e to power kt. So what y0 is, it's going to be really the population for the day before. So this is the initial population. So now this is our general formula for a growth rate. And last week I posted a video. I projected the coronavirus cases for the following dates, and my projection was wrong. And then I realized that the reason it was wrong, it was not based on the growth of the virus. It was really based on the growth of the numbers of testing, and that's why it did not work. So now let's, instead of looking at the cases, how many cases we have, the date is a fact. So let's go ahead and drive the formula based on that. So this is our general formula. But let me go ahead again, write this C for those who are in math, in differential equation. This will be more understandable. Okay. So let me write that equation here. This y is equal to c e to power kt is our general formula for a growth rate. Now let's go ahead and write that formula for these two numbers that we have. So the population on day -1, which was yesterday, the report that came out this morning was 3,141, which is equal to a constant C multiplied by the e to power k times t, and our time yesterday was -1. So this is equal to C e to power minus k. And our population, our death number 2 days ago that was reported, which was really reported yesterday, was 2583, which was for the day before. So at -2 is equal to 2583, which is equal to C e to power k times the time. Our time is -2, which is equal to C e to power -2k. Now we have couple equations. We have two equations, one for March 30th and one for March 29th. So from these two equations, let's find the values of this constant and this and our growth rate. So in order for us to do that, let's go ahead and write this as C e to power minus k. Let's go ahead and divide these two equations. We divided by each other. So we have C e to power k minus k times divided by C e to power minus 2k is equal to 3141 divided by 2583. So we can write this as, in here, C's will cancel out. So we can write the left side as e to power k multiplied by e to power minus k multiplied by e to power 2k is equal to 3141 divided by 2583. So is equal to 1.216. So on the left side, we have e to power k is equal to 1.216. So if we take the natural log of both sides, we are going to have natural log of e to power k is equal to the natural log of 1.216. So natural log of e to power k is equal to k. So k will be equal to natural log of 1.216. So this is our value for k. So our equation so far is y is equal to c e to power natural log of 1.216 multiplied by time. So now let's go ahead again. Let's go ahead write this for either number. It doesn't matter which one. So let's go ahead and do it again for the first one. So y minus 1 is equal to c e to power natural log of 1.216 multiplied by t. Let me put the t on this side. The reason I'm writing the t on the left side because I have seen many mistakes anytime when you have a natural log, you multiply the natural log, you multiply something by it and write it on the right hand side. I have seen a lot of mistakes like that. So let me put the t on the left side. And our t is minus 1. Our time is minus 1, so it's minus 1 multiplied by natural log of 1.216 equal to 3141. So here we are going to have, we can rewrite this as c multiplied by e to the power of natural log of 1.216 to the power of minus 1. We know that a natural log of b is equal to natural log of b to the power a. So we are using this formula and writing this portion like that. So this is equal to 3141. Now e to the power of natural log of that. So this equal to c multiplied by 1.216 to power minus 1 equal to 3141. So c here will be equal to 3141 divided by 1.216 to the power of minus 1 or multiplied by 1.216. So here C will be equal to 3141 multiplied by 1.216 is going to be 3819.456. So our formula now, our general formula for today is y equal to C, which is 3819.456 multiplied by e to the power of natural log of 1.216 multiplied by time. So this is our general formula. This is our general formula for the death roll, the growth of the death roll for this coronavirus at this date, on March 31st. So by the end of March 31st, the death roll will be y equal to 3819.456 multiplied by e to the power of natural log of 1.216 multiplied by, our date is March 31st, multiplied by 0. So this is 0, so we are going to have y is equal to e to power 0 is equal to 1. So by the end of the day, the total death roll will be 3,819, which will be reported by tomorrow morning. So tomorrow morning on April the 1st, this will be where the death roll should be. So I am going to calculate for the next 5 days and write down a description. And any number less than that would show how hard we are fighting against this pandemic. And we have to, every 5-6 days, we got to go ahead and do these until we get to the maximum point where that virus is going. Then when it goes down, we will be able to estimate how long it's going to last. And this is a very good example for the growth rate using the differential equations. I hope you like it, and I hope we get rid of this situation soon.